Hello physics students, welcome to today's lesson. We are going to be talking about Newton's second law. We are going to describe what Newton's second law is and some basic applications of it. In a future video, we will go through a couple example problems of how to use Newton's second law in a equation and how to look at free body diagrams. But that is in the next video. Again, if you haven't watched any of the force description videos, if you haven't watched the video or understand what net force is or what the total unbalanced force is, I encourage you to go back and watch those previous videos as they are building blocks up to this video. So that being said, let's get into it. Many of you have probably heard of Newton's second law. It's a pretty common physics law, but we're going to delve a little bit deeper into it in this particular physics class. Newton's second law says, and I'm just going to read it to you all, the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction of the net force and inversely proportional to the mass of the object. I'm sure you all got it the first time I read it, and you know everything there is to know about Newton's second law. I'm kidding. It's a mouthful, but let me break it down a little bit into some simpler, more straightforward verbiage. So it says the acceleration of an object, so acceleration, remember, is how fast something is speeding up or slowing down. The acceleration of an object is directly proportional to the net force, okay? And in the same direction as the net force. So let me provide a couple examples. So let me just write this. So force is proportional to acceleration. What this means, proportionality, if I increase my force, I increase my acceleration. If I decrease the force, I decrease the acceleration. So here's a little example. I have two markers. First marker, and I'm going to stand on this side of the table. I'm going to throw it with a little force. Doesn't go very far or speed up very quickly. However, if I throw it very hard, apply a lot more force, that marker will go fly, right? So that is what this first part of the law says. More force, more acceleration. Less force, less acceleration. All right. And in the same direction, right? If I have this roll of tape here, and I apply a force this way, it's going to accelerate that way. If I apply a force straight towards the camera, the roll of tape will accelerate towards the camera, right? So on and so forth. Whatever direction we apply the force, that is going to be the direction of the acceleration. And let me back up just one second. It's whatever direction the net force is. Because remember last class, and I'm not sure if you could see this, but Physics Pony is there. We pushed with equal forces. There was no net force, and we were each pushing with a force, but really it just matters about the net force, where the extra force is pointing and how much extra force there is. Awesome. Let's dig into the second part of that statement, and it says, and it's the magnitude of the acceleration, or how much acceleration, is inversely proportional to the mass. Acceleration is inversely proportional to mass. So what this means is if I have a really big object, let's say a train, and I hit the train, it's not going to accelerate much, right? However, if I apply a force to an ant, right, the ant will go flying. Same thing, if I have this marker and I apply a little force, right, it goes a reasonable amount, but, oh gosh, if if I have this cinder block and I apply the same force to it, it's not going to go very far, right? So that's the basic premise of Newton's second law. And to really simplify it, the harder you push on something, or the harder something is being pushed on, the more it's going to speed up or slow down. The heavier an object is, the harder it is to get that object to speed up or slow down. Same thing, if the lighter an object is, the easier it is going to be for that object to speed up or slow down. So, all that being said, just grab one of the markers I threw. Newton's second law is most commonly, Newton's second law, we could write it, acceleration is equal to force over mass. So more force, more acceleration, more mass, less acceleration. Most commonly, it's rewritten like this. F equals ma. You might be wondering what the heck this little squiggly thing is. That is the Greek letter sigma. That just means net, or added up forces. And remember, the forces added up are vector quantities. So if I have 5 going this way and 5 going this way, they actually add up to 0, not 10, right? Because the forces are opposite directions. All right, now here is some problems that are basically on your homework. Numbers are different, but the same principle is the same. But we are going to go through a couple of example problems of just thinking about the relationship of force and mass to acceleration. So this first one says, an object is accelerating at 6 meters per second squared, or 6 meters per second, when the net force is increased by a factor of 4, or the force is increased 4 times. So we multiply the force 4 times over. And I think it's easier in these problems to keep the equation like this, where we're looking at the acceleration. So my acceleration, and I'll rewrite this equation, F over m, and acceleration is 6 is equal to force over mass. Well, if I multiply force by 4, whatever the force is, right, I have to multiply this side by 4 as well. So my actual new acceleration is going to be 24 meters per second squared. So I increase the force by 4 times, my acceleration increases by 4 times. Awesome. So let's move on to the next example. An object is accelerating at 4 meters per second squared when its mass is increased by a factor of 2. Find the new acceleration. So rewriting our equation again, acceleration equals force over mass, and 4 equals F over m. Well, we increase the mass by a factor of 2. So I have a 2m. Well, if I increase what's in the denominator by 2, that's essentially dividing by 2, right? So I would have to divide this side by 2. So my new acceleration is going to be 2 meters per second, right? I double the mass, it actually makes the acceleration get cut in half, right? Twice as heavy object is twice as hard to get moving. So our new acceleration is 2 meters per second squared. All right. Now this last one is the trickiest, and that's why I saved it for the last. But it says an object is accelerating at 10 meters per second squared when a net force decreases by a factor of 2 and its mass is increased by a factor of 4. So find the new acceleration. Okay, let's try this out. And I'm going to write it over here. I think it might just be easier for you all to see with the camera. And I'll even erase. So, acceleration equals F over m. Right? My acceleration is 10 equals F over m. So my force decreased by a factor of 2. So we could say it's 1/2. Okay? And my mass decreased by a factor of 4. Ooh, fractions are tricky. So now what I can do is once I figure out the numbers on this side, I do that operation to this side. So if we remember back to fractions, if I want to divide these fractions, I would take these and flip them. So it would be 4 over 1. And so really, essentially, this 4 and the 2 cancel, and I have just a 2 left over. And since I just have a 2 on this side, I multiply by 2 on this side. And so what I'm left with is our new acceleration is 20 meters per second squared. Now if that doesn't make sense to how I did it mathematically, let's talk through it just conceptually, okay? So if an object is accelerating at 10 meters per second, and then the force is decreased by a factor of 2, so it's cut in half, the acceleration is going to go down, right? Because I'm not pushing as hard. So it's going to drop by half. So this number would then be 5. Then its mass decreases by 4 times. So it gets lighter by 4 times as much. So when an object gets lighter, it's going to be easier to accelerate. So we would multiply that by 4, and we're left back with 20. So there's just a couple of different ways to think about it. Again, really remember that force equals ma. We'll be doing this over the course of the next couple of days. You'll be digging into this a little bit more. So yeah, stay tuned for the next video. I'm going to go through a couple of example problems in how to look at a little bit bigger of a problem and what to do with it. So check that video out for a couple of examples of what to do. Thank you all for watching. Have a wonderful rest of your day.